Now one question here. So here I didn't mention anything, just it is a discussion related to regression. Now we have seen the discussion on linear regression, how to do it, and etc. etc. Right. Now here some data is given. So where it is related to some house purchasing kind of stuff. Where so what we had size of the house, that is how many square feeters and how many rooms are there. It is in which floor and what is the age of the house and corresponding price. Right. Now the discussion here is, suppose if I want to find, based on this data, if I want to find, suppose if age is 18, right, then what is the price? Right. Suppose if I want to find only this, that means here I am not considering any of the other parameters given, size, number of rooms, floors. Only thing what I am considering is age and price. So then what we have to do is, when age is equal to 18, then price I have to find. That means this is my x and this is my y, right? So by taking age as x, price as y, then we have to do the linear regression as discussed. That is by taking y equal to beta naught plus beta 1 x, right? That we can do. But here similarly, if I take only floor and price, like suppose if I want to find the price of a house where I give the size and I will give the number of rooms and also I will give the floors and also age. That is, it is like, suppose I want to find the price of the house. I want to predict or estimate the price of the house where size equal to 2200 and number of rooms 3 and floors fourth floor and age of the house is 12 years. Right? So this is the problem we have to discuss. That is, when size is 2200 square feet and number of rooms are 3 and it is in 4th floor and the age of the house is 12 years. Right? So now what to do? Then if you observe here, the y, that is price, depends on size, number of rooms, floors as well as age. That means here it is the y depends on size, number of rooms and the floors and also the age of the house. That means we need to have a relation where relation between size, number of rooms, floors and age, based on which we can try to predict y. That is, suppose if I take x1 as the size, x2 related to number of rooms, x3 related to floors, x4 related to age, then I will try to establish a linear relation, that is y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. Right? So here, what is the difference between the previous discussion and this discussion, where in the previous discussion we had only one independent variable, where by method of least square we try to find the values of beta naught and beta 1, in turn the relation between x and y. So in this case it involves more independent variables, right? x1, x2, x3, x4. So now we have to find the relation between y and x1, x2, x3, x4, which is a linear expression and which involves the constants beta naught, beta 1, beta 2, beta 3 and beta 4. Right? So this is the difference between the discussion what we had earlier and now. So how to find it, and what is this concept called? This is called as multiple linear regression. Right? So that means here multiple independent variables are allowed, multiple linear regression. Right? That means here the discussion what we had is the base. to find a linear regression line. Now there is no restriction on number of independent variables. The number of independent variables can be extended like this. Now how to find this? So we'll see. Now if multiple independent variables are involved, then how to try for the linear regression, right? So now this is already what we are familiar with. If y equal to beta naught plus beta 1 x, already we derived that is with the help of method of least square, and we used the maximum minima type of concept to arrive at these two equations, right? Now suppose if we had multiple linear regression, that is where we had two independent variables x1 and x2, and the corresponding linear expression is y equal to beta naught plus beta 1 x1 and beta 2 x2. Then the same fashion like what we discussed in terms of y equal to beta naught and beta 1 x, here what we have to do is we have to repeat the process where we, by taking dou s by dou beta naught equal to 0, dou s by dou beta 1 equal to 0, dou s by dou beta 2 equal to 0, right? So because here we have to find the values of beta naught, beta 1 and beta 2, that is we have to minimize the error with respect to beta naught and beta 1 and beta 2. Therefore, we will take dou s by dou beta naught equal to 0, dou s by dou beta 1 equal to 0, dou s by dou beta 2 equal to 0, and if on simplification, now corresponding to this we will get this equation, corresponding to this we will get this equation, corresponding to this we will get this equation. So when we try to fit a linear expression involving two independent variables, then this is the equation, then we will get corresponding normal equations. So very simple to have this. Now if you see here the same fashion, like for your understanding sake, suppose if you remember the process, what we have done is we had partial derivative this with respect to beta naught, then first one what we had got is summation. If you take summation of the expression summation y, beta naught into summation n, because it is a constant, beta 1 into summation x, okay. Now similar way here, first with respect to beta naught, if we do simply what we get is summation of this summation y, beta naught into summation is nothing but beta n, beta 1 summation x1, beta 2 summation x2, right? Now here going back, next what we have done is we did partial differentiation with respect to beta 1 and simplified. Then what we got is, if you see here, multiplying throughout by xy, xy, beta naught into summation x, beta 1 into x square. Now same here, same here. So with respect to beta 1, if we do, then what we get is x into y, x1 into y, beta naught into x1, beta 1 x1 square, beta 2 x1 x2, right? Next is continue. Now with respect to beta 2 we do, then what we get is x2, then multiplying throughout by x2, x2y, beta naught x2, beta 1 x1 x2, beta 2 x2 square. So like this, so whenever we had linear regression involving more independent variables, we can form corresponding normal equations. Suppose if you want to extend this further, like the previous example what we discussed, involving x1, x2, x3, x4, for each beta naught, beta 1, beta 2, beta 3, beta 4, we will have corresponding normal equations. Once we had normal equations, then very simple, we can plug in all the values whatever we had. Then in this case, if you see, so we'll have, after plugging all the values or the data whatever we had, then we'll have linear equations involving beta naught, beta 1 and beta 2. So on solving this system of linear equations, we'll get the values what we are looking for. That means in turn we'll get the expression, that is the multiple linear regression y equal to beta naught plus beta 1 x1 and beta 2 x2. By using this, we can try to estimate or predict for whatever the values of x1 and x2, we can find corresponding y. So this is how, so we can have the linear regression as we started with in terms of only one independent variable, one independent variable. Then we can extend it further where we can have many number of independent variables like what we discussed now, right? So thank you.